Hi, I'm Josh Steen, a developer here at ICSF, and I'm here today to talk to you about Symmetric Key Encryption. Symmetric Key Encryption. The most important part of Symmetric Key Encryption is that the encrypt key equals the decrypt key. This means that if you have either the key for encryption or decryption, you have the key for both. So let's go over an example. We have Alice, and we have Bob. And they want to communicate, but they're worried once the communication leaves their hand that somebody else might come in and read it. We'll call that person Eve. So, they decide to use encryption. So if Alice wants to send a message to Bob, Alice needs to take her original message the key they agreed upon, and run it through an encryption operation. This will produce an encrypted message. This makes it so that when the message gets sent, if Eve is able to pick up on the message, she has no idea what the contents is. But when Bob receives it, he will be able to use his key to decipher and decrypt the message. Bob does this using the ciphered message as well as his key and a decrypt operation. This will produce the original message that Alice sent to Bob and make it so that Eve, even though she intercepted the communication, has no idea what the message is. The drawbacks to symmetric encryption are that symmetric encryption requires that the key be exchanged in a way so that only the two parties communicating know what the key's value is. If Eve was able to get a hold of the key, she would be able to understand all of the encryption and all the decryption that was done for the messages and be able to fully understand what's being said. A way in which they can exchange these keys in private is essential to this encryption type. Enterprise Knights of IBM Z, providing educational insights to the security and integrity of our platform.